Question 7, A, B, and C are three equal spheres, so we have all their masses then. And we'll just call it A is set in motion directly towards B with speed of 4. So we have these three balls, looks like they're sitting like this. They're at rest in a straight line, A, B, and C. So we got to look at A and B, and then we have to look at what's happening between B and C, and then possibly A maybe catching up with them if it's keeping on going. So let's look at how the masses of A and B first here, and what's going on before and afterwards. That's the first thing that's going to happen, is that A hits B. So we have masses of M, they're equal, and A is set in motion with a speed of 4 in the I direction. Coefficient of restitution is a half. B is half. Find the speed of B after colliding with A and after colliding with C. Okay, let's look at after colliding with A. It's at rest, and we have P and Q for my speeds afterwards. So if we apply this information to our formulas, we should be able to solve for P and Q. So V1, P minus Q, P1 minus P minus Q over U1 minus U2, which is 4 minus 0, is equal to minus 1 over 2. So we get 2P minus 2Q equals minus 4, which we can divide by 2. Let's just leave it for a minute and write out our other formula. There it is. So M, they're all M's, so the M's will all cancel here. We could divide, well, we could divide across by M at the start. Let's do that, because they're all M. So we get U1, which is 4 plus the 0 is equal to P plus Q. So we could divide this bottom one here by 2. P minus Q is equal to minus 2, and bring it up to P plus Q is equal to 4. P minus Q equals minus 2. So we're going to get 2P is equal to 2, meaning that P is equal to 1. And if P is equal to 1, Q, you can see from this equation, would have to be equal to 3. So now we need to look at the relationship between B and C. So let's have a look at that then. So we have our masses are still just going to be M and M. So we have before and after. So let's look at B. B speed before is this, well, P is A, so Q, so we have 3 for B, and C is at rest. And then afterwards we'll have a P, I, and a QJ. You can give them different letters if you want, because we've already used these. But applying this information, we are going to get V1 minus V2, P minus Q, over 3 minus 0, if you want to put it in, is equal to coefficient of restitution is going to be the same. So we get 2P minus 2Q equals minus 3. So then the M's, we can keep the same formula here. We know the M's are going to cancel here. So we've got U1 plus U2, which is just 3, is equal to V1 plus V2, which is P plus Q. So if I multiply this one by 2, it might be easiest to just say 2P plus 2Q is equal to 6. Bringing the other equation down, 2P minus 2Q is equal to minus 3. We're going to get 4P is equal to 3. So P is 3 over 4. Can we see a simple solution for Q? If P is 3 over 4, 3/4, to get up to 3, we'd have to add on 2 and 1/4. So Q is equal to 2 and 1/4. Q is equal to 2 and 1/4, which is 9 over 4. 9 over 4 and 3 over 4 is 12 over 4, which is the 3 that they're equal to when you add them together from this equation. So will there be any more collisions? Let's have a look here. What's going on? We have our A, our B, and our C have all collided. Their speeds are now, this guy, 2.25 in that direction. That's C, and B is P 0.75. in that direction, and A plus this P, which was 1 in that direction. So it does look like 1A is going to catch up with B. A will collide with B. And our justification is our brilliant diagram. In this question we have spheres A and B lying on a smooth table. A has mass of 4 and B has mass of 2, 4 and 2. So what's going on here? They're projected towards each other, so that one and that one, so they're going in opposite directions. So we'll give the first one positive, 2 spheres with the same speed. So if that one's U, I can call that one minus U. Oh, they tell us it's V. Read the question first maybe. V and minus V. V, and the coefficient of restitution is E. After impact, A comes to rest. So before, after. And we'll call this Q in the I direction. We don't have it. So what are they asking us for? Show that the speed of B after impact is the same as it was before impact. Well, it's minus V here, so it needs to be plus V, I'd imagine. So let's have a look at that. So we have V1 minus V2 over U1 minus U2 equals minus E. So we're going to have 0 minus Q over V minus V, sorry, minus V is equal to minus E. So minus Q is equal to minus 2 EV, or plus Q is equal to plus 2 EV. So we apply the M1 U1 plus M2 U2 equals M1 V1 plus M2 V2. We're going to get 4 times V plus 2 times minus V is equal to 4 times 0 plus 2 times Q. So we're going to get 2Q is equal to 4V minus 2V, 2V. Well, that means that Q is equal to V. So if I say over here, I can say Q is equal to V, I can say V is equal to 2EV. Dividing across by V, I get 1 is equal to 2E. So E is going to be 1 over 2. Which is part 2 here. Whereas part 1, the speed, well, Q is equal to V. Therefore same as minus V, just in the opposite direction. If you want to put in the opposite direction. And then find the percentage loss in kinetic energy, so our half mu squared. In terms of V here, we have a half 4 by V squared. And we have a half 2 by your minus V squared. That's what's going on before. So half of 4 is 2, so we have 2V squared. We just have plus V squared. So 3V squared before. Afterwards, we have a half times the 4 times the 0 squared. And we have a half times the 2 times the Q squared. And we got Q is equal to V. So that's going to be V squared. So afterwards, we're just going to have just V squared. So it's gone from 3V squared to V squared. So that's a loss of 2V squared. What were we asked for? Percentage loss? Well, that's just 2/3. 2V squared over 3V squared is equal to 66 2/3%. You should see that straight away.